This is the Arduino CLI in action. That's what the Arduino CLI does, but what is it? Well, CLI stands for Command Line Interface. This means that instead of using your mouse to click around and make things happen, you type what you want into a command line. On Windows, you can find a command line by hitting the Windows key and typing CMD, although this is more generally known as a terminal. The Arduino CLI has access to almost all the Arduino tooling you would expect, such as support for lots of different boards and access to all the Arduino libraries. It is being developed as an open source tool by the official Arduino company, and you can find links to the documentation which show you how to get started and all of the commands you can run. We've already made a video on this channel showing you how to install the Arduino CLI, and we'll have one soon explaining all of the commands. So now that you know what the Arduino CLI is, you might be wondering, why would you want to use it? The first, and I think most important reason, is to break out of the Arduino IDE. Until now, the Arduino IDE has been the only real option for taking advantage of the Arduino ecosystem. We're all familiar with it, and while it is good for getting started, I'm going to show you what you're missing out on compared to a more fully featured program for writing software. Here is our Blink example in the Arduino IDE. If we try to add a new line and make some mistakes, we don't get any warnings until the IDE finally tells us about it when we try to verify. We have lots of different keywords and variable names to remember when trying to program, which makes it all the more likely we will get something wrong. If we swap over to a different program, such as VS Code, we see a similar layout initially, with some colours to help us understand our code. However, when we add a new line now, the program gives us suggestions and shows us what methods we can call and what type the parameters should be. This is a really helpful feature, especially as the programs become bigger and more complex. If we make a mistake, like missing a semicolon, our automatic formatting makes this really obvious. And as soon as we fix it, it all goes back to looking really nice just the way we want it. Next, we can open up a different file type for running in the command line. This is a short program which will compile the sketch and upload it to the Arduino using the Arduino CLI. We can also look at a Python file, which is a different programming language, all in the same program. The Arduino IDE doesn't work very well for other programming languages, so being able to look at all our code in the same program is a big improvement. So we'll quickly open up a terminal, compile and upload the sketch, and read from the Arduino using our Python program. This is just a quick demo, but I hope it shows you a little of what can be done now that we can break out of the Arduino IDE. Another reason to use the Arduino CLI is Dependency Control. If you've been using Arduino for more than a few projects, this has probably bitten you before, and the CLI provides a nice solution. To explain, if we start a small project which uses a library for measuring temperature from a sensor, that library depends on a specific Arduino version, specific to the board which we're using. In the IDE, you can install libraries through the Library Manager and boards through the Board Manager. Now, that dependency means that the person who wrote the library intended for it to be used with a specific Arduino version, and it might not work with another one. Similar to how a program you install on your computer might not work until you update the operating system. If this is your only project, then everything is fine. But what if you start a new project which uses an accelerometer library that depends on a different Arduino board version? With the Arduino IDE, this is going to be a problem. Only one of your projects is going to work at a time, because they need different Arduino versions, and you can only install one at a time. If you want to share your project with somebody else, you need to tell them to install the same Arduino board version and hope that they install it correctly, or your project won't work for them. The Arduino CLI gives us the tools to solve this problem, making it easy to specify which version of libraries and boards are needed for a specific project. And it provides a way of isolating packages for each project so that they no longer interfere with each other. This solves a big pain point for using Arduino reliably in more complex projects. Finally, if you're using Arduino in a serious application, you might want to think about automated workflows, also called continuous integration. This is now a common tool for software projects, but it can provide a lot of value for embedded projects as well. Even something simple like making sure the project compiles every time you share it can save a lot of energy trying to track down why it works for you but not other people. In a future video, we'll look at how unit tests and integration tests can be used with the Arduino CLI. When the only option was the Arduino IDE, this would all have been very difficult to do, as you would need a machine that had a screen, which adds costs, or look into compiling the project without much help from Arduino, which is quite difficult. Now, the Arduino CLI means that this is only a few lines in a configuration file, and you can send something like this to a continuous integration service, such as GitHub, GitLab, or Travis CI, and it will let you know that your project is happy and all the basics are covered. Thank you very much for watching. I hope you've learned a bit about why you might want to use the Arduino CLI. We have more videos on the way showing you how to use the Arduino CLI to build your own projects. So comment down below on what you'd like to see it used for, and if you enjoyed the video, please give it a like. See you next time.